Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 1962. Remove stones to minimize the total. In this video, we're going to give a solution based on the simulation with the help of a heap. So first, I'm going to read through the problem statement to digest the requirement. And then we do the code directly, and in between, we explain the logic. First, let's look at the problem statement. We are given a zero-indexed integer array piles, where piles I represents the number of stones in the ith pile, and an integer k. We should apply the following operation exactly k times. So we choose any pile and then remove this amount of stones from that pile. So notice that we can apply the operation on the same pile more than once. So we are required to return the minimum possible total number of stones remaining after applying the k operations. In other words, apply the above operation exactly k times. So here, floor is a mathematical operation, which means the greatest integer that is smaller than or equal to x. In other words, rounds down. So with that said, let's look at the two examples. So in example 1, so let's take a greedy strategy. So pile 2 has the largest amount of stones, so we can remove roughly half, that is 4, to this. So and then we remove 2 from the first pile. So in total we removed 6, right? So then we have remaining 3, 4, 5, that is 12. So this is 12. So I mean the total number should be 5, right? So in example 2, so k equals 3, so we can remove 3 from here, 3 from here, and then 2 from 4, any of the 4. So the total remaining is also 12. So before we do the coding, let's also look at the constraints. First, the list piles has length bounded above by 10 to the power 5. And each pile has at most 10 to the power 4 number of stones. So lastly, k is bounded above by 10 to the power 5. So with that said, we are ready to do the coding. So for this problem, we are going to make a simulation. So with that, I'm going to use min heap. So in this way, we can take advantage of the Python implementation of the heap data structure. So for that purpose, first I'm going to make negative of this pile. So because this way, the smallest element will correspond to the largest number of stones if we take consideration of the negative sign. So let's first do this using list comprehension. So negative item for item in piles, right? So this is our first preparation. And then we're going to use this heapify function to make this list a pile, a min heap. So piles, right? So with that done, so actually we can initialize a variable called nSteps to monitor how many operations we have used, right? So well, nSteps is less than n, right? Then what we are going to do? So we are going to pop from the heap queue, heap pop, right? So pop from the piles. So this is a negative largest number, right, in the sense. So then what actually we can remove is this amount, so mass floor of negative current over 2, right? And then the remaining one will be negative current minus this number. And then we want to push back the negative thing. So we are doing this, right? So this is the remaining. Let me introduce this variable just for convenience. This is the current, right? This is a negative number. And this is the half, roughly. And then overall, this is still negative, right? Not non-positive, at least. Then we are going to do heap q, heap push, right? Now I'm going to push 2 piles and push back this amount, remaining one. So actually you can directly push this number, right? So without the necessity to introduce this r variable, but I introduce it here just for convenience or clarity. So once we do the pop and push back, then we finish that operation. Then we increment this in steps by 1. So after we exit this while loop, we actually have done exactly key operations. And then we just need to return the remaining number of stones in the list, in the heap. So I'm going to do for negative atom for item in pairs. So this is what we need to return. So here actually we are using a comprehension again. So with that said, let's first do a check. So here n, okay, so let me, this is no n, this is the k, right? Yeah, it passes the second example. Now let's look at the first example. So k is 2, right? Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this specific problem. So here we provided a solution based on the simulation with the help of heap. So you can actually digest the logic and come up with other formats of coding for this problem. With that said, I guess that's the end of this video. Thank you.